I believe this is where we left off yesterday, yes? Okay. So we're continuing on with finding the product of two rational expressions. We did this one? We're on this one here then, yes? All right, so we're going to do, there's different ways to do it, and we went over a few. One was multiply then simplify, and one was simplify, multiply then simplify again. And I think between the two, we like to just go on and multiply them together and then simplify all at once. And we multiply two rational expressions. We multiply numerator with numerator, denominator with denominator. So the first thing we're going to do is 6 times 3, which is 18. X to the 5th times x, so we add our exponents when we multiply bases, yes. So it would be x to the 6th. And y squared times y squared is y to the 4th, yes. In the denominator, we have 8 times 9, which is 72. X times x to the 3rd would be x to the 4th, yes. And y times y is y to the 2nd, y squared. So we multiply everything together on top, everything together on bottom. And now we're going to simplify. So the first thing we can simplify is the 18 over 72. So there's different ways we can go through it. We can go through the factors of 18, factors of 72, and see what the biggest number that goes into both 18 and 72 is. Or we can 18 over 72 in the calculator and let it reduce it for us. And it turns out the greatest common factor between 18 and 72 is, well, 18. So the number on bottom is going to become 4. The number on top is going to reduce to 1. But since we do have some other terms left, we'll put the other terms in, see if something takes its place. If everything in the top of the fraction is reduced, we'll write it as 1. Because there's not a whole lot of reason to write 1 and then x and y. Let's see what happens. X to the 6th over x to the 4th. When we divide like bases, we subtract the exponents. So 6 minus 4 is 2. Is it bigger on top or bottom? Top, so it stays on top as x squared. Y to the 4th over y squared. 4 minus 2 is 2, so y squared. And since it's bigger on top, it stays on top. So we finish with x squared, y squared over 4. And our restrictions would just be x is not 0 and y is not 0. Questions on this here? So I have a feeling that we kind of doing these monomial terms on top and bottom is nice. Now we're going to look at some polynomial terms. Now we multiply these here, these rational expressions with polynomials as the numerator and denominator. The first thing we're going to do is factor them. So we're going to factor them, multiply, simplify. So that's the only difference between our monomials, terms the ones we just did, and these here. Now again, I would look for whichever one's going to factor the easiest first. I would go with 3x. It's a single term. There is no greatest common factor. There's nothing we can do to 3x. It is just 3x. The next one I would look for is anything that has a greatest common factor between the terms, on top or bottom. Well, in our first one, we have 3x and negative 3x squared. Well, what's in common with 3x and 3x squared? We would have a common factor of 3. We'd also have a common factor of x. Because both of them do have 3. Common factor, greatest common factor between 3 and 3 as well. 3. And the greatest common factor between x and x squared is x. So if we factor in 3x out of 3x, it reduces it to 1. Minus, when we factor a 3x out of 3x squared, the 3 factors out completely, and the x squared becomes x, leaving us with 1 minus x. Not preferable because normally we want the x, the variable with the biggest exponent, positive, but we'll leave it for now because we might not have to change it, but we'll see. Now the x squared plus 4x minus 5 or x squared plus x minus 20, which one of these do we want to factor first? Doesn't matter which, we'll have to do both. 4x. Now x squared, 4x, and 5, there is no greatest common factor between these three terms. So we'll move on to our two sets of parentheses with three spaces. Now since the third term is negative, our signs are going to be opposite. One's going to be positive, one's negative. The factors of x squared are x and x. 1 and 5. 5 first, 1 second. And again, we can check and make sure. X times negative 1 would be negative x. 5 times x would be positive 5x, so plus 5x. Negative x plus 5x is positive 4x. Is that the middle term we wanted? Yes, okay. Now that leaves us with our last one, the x squared plus x minus 20. No greatest common factor between x squared, x, and 20. So we'll have our two sets of parentheses with three spaces. Since the third term is negative, our signs are opposite. Factors of x squared. X and x. Factors of 20. 5 and 4. 2 and 10. 1 and 20. I have a feeling we're wanting 5 and 4, yes? Now, again, we want things to simplify. We want something to be the same on top and bottom, yes? Well, one of the terms we have on bottom is what? X plus 5. 5 is a factor, so if x plus 5 is a factor of this, I'll have something in common on top and bottom that would reduce, make the 4 negative. And if we check this here to make sure, x times negative 4 is negative 4x. 5 times x is plus 5x, giving us the positive 1x that we wanted. So we can, first thing we'll do is multiply, but yes. Any questions on how we got to this point here? Now at this point we're going to multiply them together. Now, whenever we have two sets of parentheses, like the x plus 5 and x minus 4 written next to each other, they're being multiplied, yes? So if we multiply everything on top, we do have 3x times our 1 minus x. It's being multiplied by our x plus 5 times our x 4. So we are multiplying them all together, but it just looks like we just smushed everything on top together. Same thing's true for the denominator, the bottom. I like to put the monomial, our greatest common factor terms, up front, just so it's easier to keep track of them. It's kind of odd having a 3x at the end or in the middle. Now, what's in common?
X plus 5.
X plus 5 and x plus 5. Here, the 3x and 3x simplify out completely as well. Now it is interesting that 1 minus x and x minus 1 are very similar to each other. They're not the exact same. But I wonder, let's just try something. What happens if I factor a negative out of the x 1 minus x? Well, the negative x is going to become what? Positive. We pulled the negative out, yes? What's going to happen to the positive 1? Then we can factor this out. Now, the only reason that's going to work is if every term in the one set of parentheses is the complete opposite of the other. Because on bottom, the x was positive, but on top, the x was negative. On bottom, the 1 was negative. On top, the 1 is positive. Both terms were flipped, so taking that negative out helped. Or the other thing we could have done from the start is factored out that negative to try to keep that x positive. Because keeping the x positive, that biggest variable with the biggest exponent, positive does help us in the end because we normally want that x to be positive. Questions on what we did here? A lot of factoring, a lot of manipulating, and then simplifying, yes? Let's look at the next one. And again, 5x, nothing we can do with it. (5x minus 5x squared). We do have a greatest common factor between these two terms, yes? And it is what? 5x. Now, just like the last one, that x squared term is negative, yes? Well, we had to end up taking the negative out eventually. Why don't we just take it out now? Because again, that 5x is going to become 1. The 5x squared is going to become what? X. If we don't take the negative out, that 5x squared is going to say negative x. Because negative 5 out of negative x squared is going to become positive x. If we take the 5x out of 5x, we do get 1, but because we took the negative out, it's going to become negative 1. We'll fix it here in a second because normally we could have just wrote this as x minus 1. I kept it in this form just so we can see what's matching up with what. And we're not factoring something out and flipping two terms all at the same time. Does that make sense? All right. Questions so far? What do we want to factor next? Bottom, x squared minus 4x plus 3. Since the third term is positive, the signs are the same and match the sign of the middle term. Negative and negative. Factors of x squared. X and x. Factors of 3. 1 and 3. And if we do check this here, this is the correct factors. We'd have negative 3x minus x, which is indeed negative 4x. But also, this is the only way we can have this written. X squared minus 5x plus 6. There is no greatest common factor. We would have x and x. What would our signs be? Negative and negative. Since the third term is positive, the signs are the same and match the sign of the middle term. Factors of 6 are? Which one do we want to try first? What's on bottom? Because we have x minus 3, yes? Well, if we do have 2 and 3, x minus 3 and x minus 3 would match up. Doesn't necessarily mean that this is the correct set of factors. If we do check this here, x times negative 3 would be negative 3x. Negative 2 times x is negative 2x. Okay, it does give us the middle term of negative 5x. We do have things that will simplify. All right, we're going to multiply these together. On top of the negative 5x times, we can flip that around and say x minus 1 times 2 x minus 3. I'll set of parentheses. Over on bottom, we have 5x times x minus 1 times x minus 3. Let's see what simplifies. Well, x minus 1 and x minus 1. X minus 3, x minus 3. We also have the 5x and 5x. Leaving us with, we do have the x minus 2, but we also have the negative. So the biggest part of this here is just what? Factoring. We factor it out, we factor it down, multiply, simplify. Questions on this here? Questions on any of these so far? Two x squared minus 10x over x squared minus 25 times x plus 3 over 2x squared. Is there any of these numerators or denominators that are simplified? That there's nothing we can do to them? There's actually two. X plus 3. There's no greatest common factor between x and 3. And since the degree is 1, it's done. We can't factor. Now, can we simplify eventually? Maybe. What else? 2x squared is a single term. There's nothing added to it, subtract from it. It is just 2x squared. So really the only things that we can factor are the 2x squared minus 10x and the x squared minus 25. 2x squared minus 10x, is there a greatest common factor between 2x squared and 10x? 2x. Because 2 will both go into 2 and 10, and x will go into both x squared and x. Now if we factor 2x out of 2x squared, we're left with just x. Minus, if we factor 2 out of 10, we divide 10 by 2, we get 5. What happens to the x? Let's factor it out, simplify it out, it's just 5. We get x minus 5. The denominator is x squared minus 25. No greatest common factor, but it is what? A difference of perfect squares, yes? Because x times x is x squared. What times itself is 25? So this would factor to what? X 5 and x minus 5. Let's see what simplifies. Well, the 2 over 2 will simplify completely. The x minus 5 and x minus 5 will simplify completely. However, the x over x squared, they will simplify, but they will not cross out completely. Because x over x squared, we subtract, so 2 minus 1 is 1. Is it bigger on top or bottom? Bottom, so the x stays on bottom. So one of the x's on top and bottom simplifies out, which leaves 1 on bottom. And that's everything that'll simplify. So we still have the x plus 3 on top and the x plus 5 on bottom. Questions on this here? In some ways, this is a little bit nicer. I mean, monomials in this, really, once you get it factored, stick it all together and cross out what's in common on top and bottom, and you're done. The factoring is the big hitch to this. Questions on this here? Yep. Now again, one of the biggest things I would say is factoring whichever one you can see the factors of first is going to help. Simplify and reduce. Now we have a cubic, a sum of 2 cubes, or c to the third plus 8. Then we have 6c to the 6th minus 4c to the 5th plus 4c to the 4th. And we have c to the 5th minus 4c cubed. Let's start with this one here. Is there something in common with all 3 terms? C. Because all 3 do have the variable c attached to them, yes? How many c's can we take out? 4. So all we're going to do is reduce the exponent of c by 4. So c to the 6 is going to become c to the second minus 4. C to the 5th is going to become c plus 4. And c to the 4th is going to become c to the 0. And anything to the 0 power is just 1. So it would be 4 times 1, which is just 4. Let's look down here. C to the 5th minus 4c cubed. What's in common with these two terms? What power? To the 3rd. And if we factor out the c cubed, we're left with c squared minus 4. Questions on what we've done so far? Now, we talked about sum and difference of two cubes. I said that the quadratic part, the bigger of the two parentheses, will never factor ever. It's not factorable. Yes? Let's mess with it before we start messing with the c squared minus 2c plus 4. Now, our sum of two cubes in the general form came in this here. A plus b times a squared minus ab plus b squared. Let's see what matches up with a and b. Well, a cubed is in the same place as c cubed. So let's see what a is. And to find a, we take the cubed root of c to the 3rd, which is c. Yes? All right, let's find b. B cubed has been taken the place or been replaced with 8. So b would be 2. This bigger part is starting to look very much like our c squared minus 2c plus 4. But let's verify first. So when we plug this in, a cubed plus b cubed, the first part is a plus b. So a is c plus our b is 2. So it's just c plus 2. Inside the bigger one, we have a squared, which will be c squared minus ab, so c and 2, plus b squared. So we'll write it this way. It's good to write it this way, even though this one's very simple and we could have just said that c squared is c squared, that our c times 2 is 2c, and that 2 squared is 4. I put it this way just in case the numbers get bigger, we're not mixing things up. But this here is very much hinting at the fact that this is the same as our c squared minus 2c plus 4. Yes? Because if we simplify this sum of two cubes, the top of it, we do get c plus 2. C squared is, well, c squared. C times 2 is 2c, and 2 squared is indeed 4. So we can say that that set of parentheses and the one on bottom are the same, yes? Questions on this here? So we can see how those line up, yes? Now, I've already said, and it is true, that c squared minus 2c plus 4 is not going to factor. The quadratic part of a sum or difference of two cubes does not factor. But even if it did, those two are already the same, yes? Same exact thing. So even if they did factor, their factors would also be the same, yes? So they would simplify out anyways. There's not a whole lot of reason to simplify them, even if they were. Let's factor the other two. C squared minus 4 is a what? Difference of perfect squares. So it'd be what? C plus 2 and c minus 2. And the last one we need to factor is c squared minus 4c plus 4. Since the third term is positive, the signs are the same and match the sign of the middle term. Minus and minus. Factors of c squared are c and c. Factors of 4, 2 and 2, 1 and 4. Because it'll be 2 since we'll match up with our c minus 2. If we check, c times negative 2 would be negative 2c. Negative 2 times c is negative 2c. And negative 2c minus 2c is indeed negative 4c, our middle term. So we're going to multiply them together, yes? What are we doing? Just merging everything together, yes? And I think by this point you all are tired of just rewriting that again. We're just smashing them together. We're making it all into one fraction, yes? Now let's see what simplifies. Well, c plus 2 and c plus 2. C minus 2 and c minus 2. And we also have c squared minus 2c plus 4, c squared minus 2c plus 4. Now the only thing that we have left that needs to simplify is c to the fourth over c to the third. Dividing like basis, so we can subtract the exponents. 4 minus 3 is c. And is it bigger on top or bottom? Top, so it stays on top. C minus 2 is also on top. Is there anything left in the bottom of this fraction? No. So the denominator reduced to 1. We don't have to write the fact that the denominator is 1, it's understood. But if the numerator reduces to 1, we have to write that it's 1. Questions on this here? We feel comfortable with this here, kind of what's going on. Because it's less of, even though this here seemed like it had a lot going on, it's a very complex problem. When we factored it bit by bit, it actually reduced itself quite nicely, yes? Okay. We're going to skip to 24. We're going to look at the last two problems here. X plus 2 over x cubed minus 27 times x squared plus 3x plus 9. Now there is no denominator with our second expression, the x squared plus 3x plus 9. But there is one, it's just not written. What is the denominator for this here? 1. So we really do have two rational expressions, just the second one's denominator is 1. Looking at the first one, the x plus 2, unfortunately, is not going to reduce. X cubed minus 27, difference of two cubes. Let's find our a and b. So the cubed root of x to the third is going to be x. That's our a. And the cubed root of 27 is 3. That would be our b for this here. So we can go through the other side plugging in a and b. A is x, b is 3. So a minus b for us here would be x minus 3. Our a squared would be our a terms squared, so x squared. A times b would be x and 3. Plus b squared would be our 3 squared. just like with the previous one, it looks like that bigger, the quadratic part, is going to work out to be our x squared plus 3x plus 9. And when we simplify it, we actually do get x squared plus 3x plus 9. We could rewrite it, or we can just connect those two, make it one big rational expression. Now, what's in common on top and bottom? 3x plus 9. Anything else? No, so all we're left with is what? X plus 2 over x minus 3. Questions on this here? Questions on anything we've done so far? We feel pretty comfortable with this here? Because if we notice with most of these here, the multiplication isn't really the big part. It's the factoring. It's all about the factoring. Because if we went through this one here, the x cubed plus 8 would factor to x plus 2 times x squared plus about root 4x minus 2x plus 4. And this is going to be multiplied by our x squared. And again, these would cancel, telling us that we have x minus 7 over x plus 2. But some of that's just knowing how they factor. More than anything else. Questions on this here? That's really it.